Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yeah? So we're on day 4, which means warm-up number 4. Let's go. It's already on the screen. Also, FYI, BTW, I am recording this session. If you notice down there, my recorder is going. So when I call your name to participate, you're going to be immortalized on YouTube. Let's go. Let's go. So, I'll give you guys some time. Warm-up number 4 says, compute the sum, difference, product, and quotient of negative 33 and 10. After that, get a Cornell note ready, please. Go. All right, here we go. Number 1, sum. Start with Lorenzo. What'd you get for number 1? Negative 23 microjoules. Hands if you got that. That is correct. Let's go to the difference. Difference. Show your neighbor really quick. Difference. All right, good. All right, what'd you get for the difference? Let's go with Sarah. What'd you get? Negative 43. Hands if you got negative 43. That is correct. So far, so good. Product. One more time. Show your neighbor before I call on someone. Product. Negative 33 times 10. Let's go with, how about Martin? What'd you get? Negative 330. Hands if you got that. That is correct. And last but not least, quotient, which is division. What you get for the quotient? Show your neighbor one more time. What you get for the quotient? All right, let's go with, how about Eileen? What'd you get? Negative 3.3. That is correct. And put the wiggles on. Approximately. All right, not bad, yes? All right, tell your neighbor what to do right after the warm-up. What do we do right after the warm-up? Yeah, agenda. Copy the agenda right underneath, please. Warm-up number 4, Best Fit Lines. Tonight's home plate, only one problem for home plate. What? Oh, yeah, we got this. All right, now to have access to tonight's home plate, one problem only. Write this code down. Nearpod code K3E2I. 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 So you're going to go home. You're going to go to Nearpod, type that code, and it's going to send you to this presentation, which has the problem coming up on the next slide. You'll see that on the next slide. Okay? So then you got home, you got your flaming hot Cheetos or Takis, whatever, and then all of a sudden Nearpod, type in the code, and then you scroll through each of the slides. Some of the slides are going to say to write on them, just scribble something so you can move on to the next slide, and then till you get to this one. To this one that says home plate. All right? So we'll get to that in a little bit. So with that said, last night's home plate was have a great day. Do you guys have a great day? Right? All right. Get a Cornell note ready. There's your objective. Let's read. Well, I'm going to read the objective. I can model linear relationships, also known as best fit lines. I can model linear relationships, also known as best fit lines. I can model linear relationships, also known as best fit lines. That goes at the bottom left of your Cornell note. So by now, some of you already have your notebooks. You set up your Cornell note, write the objective at the bottom. Now, you do need a fair amount of today. That big box, remember where it goes on top. Make sure you set that up. I'll give you some time. So, If I was to ask you, what is the concept for today? Tell your neighbor, what is our concept for today? Yeah, linear relationships or best fit lines. That is correct. And what are we going to do with that? We're going to model. No, we're not running the walking the catwalk or anything like that. We're actually going to graph and stuff. You're like, what? Oh, yeah. Hit the road right away. All right, so with that said, where does this green stuff go in our Freyer model? It goes in the center. Write it in the center, please. Linear relationships or best fit lines. Linear relationships or best fit lines. Linear relationships or best fit lines. What are they, Mr. Q? Definition in blue. A straight line that best fits and provides a good description of the set of data. A straight line that best fits and provides a good description of a set of data. A straight line that best fits and provides a good description of a set of data. Now check this out. This is just a review session. You should have already seen these before. But what I'm trying to establish with today's session is so that you can see how the lesson's going to flow. We did the warm-up. We did the agenda. You copied the code for the home plate. And we get started with the objective and our Freyer model. Okay? So here we go. I give you a definition. You wrote it down. And I read it like 1,000 times already. Here goes 1,001. A straight line that best fits and provides a good description for a set of data. So, do me a favor, writing utensils down. You'll finish up in a little bit. Writing utensils down, look up to the screen. Here it goes. I'm going to show you an example for a best fit line. Let me show you a non-example. Tell your neighbor why this one is an example and why not that. Talk to the neighbor. Everyone, why? What makes it a best fit line, people? So guess what? That's what we call attributes or critical attributes. So here on this box, I want you to write hashtag straight line. That is correct. It has to be straight. And then I'm going to send you the rest to your screen so you can copy it on your notes. There it is. Copy the example and non-example as best you can, please. I'll give you guys some time. Go. So let's see. We started with a warm-up, agenda, copied the code for the home plate, objective, did our Freyer model. Notice that we haven't even started doing stuff with it. This is so that you know what you're looking at. Do we know what we're looking at now? Yeah, they're called best fit lines, but it's the actual straight line. Now let me just elaborate a little bit more so that you can see a couple more things that I see. All right, here it goes. Writing utensils down, look up to the screen. So this is a best fit line. The points that were given is called data. Data points. There they are. Now, Mr. Q, what makes it a best fit line? Well, a best fit line has to follow the data. Data in a graph is always read from left to right. So if you start with 1 point on the left, keep going to your right. What do you guys notice on all those points? They keep moving in which direction? Upward, is that correct? From left to right, they keep moving upward. So that means we need to sketch a straight line that goes with the flow. However, it needs to have two things. The first one, it needs to split the data evenly as much as possible. What does that mean, Mr. Q? That means that the points above that line should equal the points below the line. So how many points above? 1, 2, 3, 4, 5. How many points below the line? 1, 2, 3, 4, 5. As much as possible. Are we always going to have 5 and 5 or 3 and 3? No. There's at times that you're going to have 6 and 4, 7 and 5, something like that. But try and split it as best as possible. Are we there? The second thing, it has to intersect at least 1 or 2 of the data points. 1 or 2. What do you guys notice on the none example? It intersected all the points, and it's not a straight line. Okay? All right. So, below that, I want you to write this down, please. Determining association. Determining association. Right underneath your Freyer model, write that down. Determining association. All right, so the first one, it's a little quadrant, and it's labeled no association. The second one is positive association, and the last one is a negative association. So, the reason we need to clarify this, because some of you are still kind of like iffy in regards to how do you read the graph. So here it goes. Writing utensils down, look up to the screen, you'll finish up in a little bit. I'm going to start with a positive one since I already showed it on the example. Here it goes. Positive association, when we go from left to right, usually starts low and goes in which direction, everyone? Upward. Everybody see that? All right, copy that, please, on your notes. So once again, positive association usually starts low and it goes upward from left to right. Therefore, tell your neighbor what a negative association will look like. Talk it over to your neighbor, please. What would that look like? All right. So a negative association, tell me where to start. Let's go with, how about, go with Gloria. Where shall I start? On top, okay. And then go down. So copy that, please. That is correct. Usually starts somewhere up there. Sometimes it's not going to go all the way up, but maybe around here and then going downward from left to right. And last but not least, tell your neighbor what do you think, if this is a positive and that's a negative, what do you think no association is going to look like? Talk about your neighbor. What do you think about that? All right, let me show you what it looks like. Now that you talked about it, here it goes. What do you guys notice? Neither going up or down. It's just kind of like all scattered all over the place, right? So copy that, please. And send me a picture of your notes. I want to see what you did on the screen. Thank you. All right. So, is this a good refresher? Is this hitting that long-term memory of yours? Is it coming back little by little? Yes? Okay. So, to get us started, after we answer the phone, somebody answer the phone. Thank you, Gloria. So we good, yes? All right, so do me a favor, turn your paper over, please, to the back side, because we're going to need some space. So this is what we do next. Before you write anything down, pay attention, look up. So this next activity, we're going to gather data. And this is how it's going to go. It says, graph the data and identify, sorry, give me a second. There it is. My bad. It says, graph the data and identify the best fit line for shoe size in Mr. Q's IM3 class. So what does that mean? That means that you're going to get up and you're going to get shoe sizes of people in here. How many people? You need 15 people. Now, before you do, this is what you're going to do. Look up. I'm going to model this. Get it? Model it. So let's say I get up and I go and I take my notebook and I'm like, excuse me, what's your name? Michael Jordan. All right, so I write MJ. What's your shoe size? 16. Okay. Then I go to the next person. Hey, what's your name? Larry Bird. Larry Bird, LB. What's your shoe size? 18. All right, and I go to the next person. What's your name, sir? Sharp. What's your shoe size? 26 triple E. Oh, snap. And so on and so forth. So this is where you're going to go. Side by side, initials with their shoe size. You need 15 people. So everybody get up, start filling your notebook. I'll give you guys some time and go. Okay, so now that we have our data gathered, I'm going to the next step, which is to model a best fit line. Are we there? So today it was about defining and modeling the best fit line. Is that correct? So here we go. So to model a best fit line, I need first data. So in order to make it a little bit more real, I'm going to use one of your data. Now, this is what you're going to do with your numbers. You're going to mimic what I do. Are we there? Here we go. So it says, shoe size for Mr. Q's IM3 class. You wrote the initial size. But that's too broad to look at. So let's say I ask Carlos. Carlos, give me your number. So imagine you guys are people that I send out to gather information, and I'm the boss, and then you come back, and I'm going to start asking your information back. So Carlos, give me numbers only. Yes, your numbers. The ones you wrote down on your paper right there with initials, but just the numbers. No initials, just numbers. Hold on. 10 and a half. 10 and a half. 6. 10 and a half. 8. 11 and a half. 6 and a half. 6 and a half. 7. 8. 9. 10. 10. 6, 7. Is that it? All right. So first thing I do is organize all my data, just the numbers themselves. So like that, we can get rid of all the initials, but the reason I have you get initials so you can have the data to know where you pull that from. Step 2, I'm going to organize that data in an input-output table. However, for the X is the shoe size. However, I need to go with the smallest number. So I look at my data. What was my smallest number that I was given? The smallest number looks like it is 6. So I would start at 6, then go to 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5. And I think that's the highest number, right? All right. From there, pay attention to the next step. I'm going to tally for each one of those. Yes. Oh, it's frozen. Let it go. Let it go. There it is. All right. You guys should have told me earlier. Bah. What's that? No. This is my data. You have your own numbers, right? So what you're going to do, you're going to first list your numbers with commas, like that. Second, you're going to list your table starting with the smallest number and then go by half. And then the third thing I'm going to do is do tallies. Here we go. Look up. I have how many sixes? Let's see. 1, 2. 1, 2. Next, 6.5. 1, 2. With your own numbers, yes. Next, 7. 1, 2. Or how they said it earlier, 7. 7.5. None. 8. I got 1, 2. 8.5. None. 9. 1. 9.5. Nope. 10. I got 1, 2. 10.5. I got 1, 2, 3. 11. Nope. 11.5. 1. So now that I have all my data in a table, now I can model it. Here it goes. All right, let me interrupt you really quick. Write your utensils down. Look up to the screen. Whenever you are given data such as this, and the data only has a certain amount of numbers that's the lowest. Let's say this one, the lowest was what? 6. To indicate that in here in our modeling, we won't show 0 all the way to 6. All I'm going to do is this. What does that mean? That indicates that there's some data missing. Data missing. And what number should come up next right there, everyone? Yeah, 6, then 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5. I'll stop at 12. All right, I'll give you guys some time to do your numbers, and then I'll continue with that. All right, so some of you are already there with your table. You started setting up your quadrant here. So now let's go to the Y. So this is our shoe size, and this is the number of people with that shoe size. Okay, so look at my tallies. What is the minimum amount of tallies that I have? 1. What's the maximum? 3. So that means I need to divide this into 3. So that means I go 1, 2, 3. Some of you have more tallies, so that means you would go from 1 to 4 or 1 to 5, whatever that may be. And once we have that, now we can start modeling our data. Here we go. 6, 2. 6, 2. 6.5, 2. 7, 2. 8, 2. 9.1. 10.2. 10.53. 11.51. All right? So, question to you all. Does that have a positive correlation, a negative correlation, or no correlation? Talk it over to your neighbor. What do you guys think? Positive, negative, or no correlation? All right. Looks like Edgar's got it. Very good, Edgar. I see you. All right. Let's see. What do you think, Dylan? Does it have a positive, negative, or no correlation? Dylan says no correlation, and I would assert with him that he is correct because the majority are going just straight like that. Everybody see that? So this is what I would do for my best fit line. Look up, please. I would do this. My best fit line would fit all of these points like that. Do we have even number of points above and below? There's one above to below. Is that pretty close? Yes. So that's what I would do. So this is called my best fit line. Best fit line. So look at your data. And sketch your best fit line for your data. Yes. Just across, as long as it follows the trend of your data. Yeah. It has to be at least intersecting 1 or 2 points if you're following your data. It has more, then that's fine. Notice these, they're all 2s. That's why I went straight through the 2s. All right? Now, here we go. Last thing, look up to the screen. The last thing that they're going to ask you on the home plate is to write an equation for that line. Let's see who remembers this. Y equals mx plus b. A lot of us, right? I'm going to write the m in green because that's known as the slope or the rise over run. Let me write that over here. Rise over run. And I'll elaborate on that in a little bit. And the b, I'm going to put that plus b, is known as my y-intercept. Y-intercept. Without the last s, y-intercept. All right. Looking at my green line, where is that line intersecting the y-axis? Tell your neighbor, where is that line intersecting the y-axis? It's intersecting at what? At 2. So I would write plus 2. However, I want you to think on this one. What do you call when there's a flat line like that in regards to slope? Think about it. Don't say it out loud. When there's a flat line like that, what do you call the slope? Tell your neighbor. What do you call the slope? All right, I think Leo's got it. Very good, Leo. I see you. Brooklyn's got it. I see you, Brooklyn. All right. Michelle's got it. Very good. All right, let's go with Jacob. What do you think? Undefined? Close. Undefined is when a line goes straight up, kind of like if you're on a skateboard, you put the skateboard on the line like that. Since it doesn't have any grip, it just falls straight down because it doesn't have any either rise or run. This is called a what? Zero slope. Zero slope. So I would write 0 times x. 0 times x. So, if I simplify that equation, my equation is y equals 0 times x is 0, so that leaves us with 2. That's the equation to that line, to my best fit line. So for home play, I gave you guys a problem that mimics, they already give you the data, you plot the data, and I want you to draw a best fit line and see if you can come up with an equation for that, all right? You can go ahead and put your stuff away. You got about 30 seconds to the bell. Once again, you have the code for the home play. Make sure you go to Nearpod at home and do that by yourself. All right, those of you that are following on YouTube, just take notes, do your practice, and I'll see you guys next time. Peace.